All right, we're back. I'm going to continue on with the rest of the question for the review. So the next question here is the linear equation word problem there. So this is a question 6. Let me go back here. Okay, so this is kind of a mixed problem that we have that you guys seen in the class. Okay, so let's take a look. So let's say Bobby opened his piggy bank and found that it contained 47 coins. Okay, worth $9.50. Okay, determine how many dimes and quarters were in the piggy bank. Okay, so here's the the dime is a 10 cents. That's 0.1, right? So we're just going to write the dime is equal to 0.1. That's the 10 cents. And the quarter is a 25 cents. So we're just going to say 0.25. We are not going to name the two different variables for this one. Okay, so we're just going to say, let's say dime is going to be equal to x. So I'm just going to say dime equals to x. So if that's the case, then, there are a total of 47 coins. So the quarter must be 47 minus x, right? So here quarters. Okay, I say dimes and quarters. That's just simply the whatever the dime you have, and then you subtract that number of dimes from the total coins. That will give you quarters, right? So that will be a 47 minus x. All right, so that means that we can set up the equation to solve this problem, right? So we have 0.1. That's how many times you have. We're going to have to multiply by the number of dimes because we know that the total money with the 47 coins is 950, right? So we're going to have to find out how much is worth is a dime and quarters that equal to 950. So here we have a worth dime is a 0.1 and number of dime is going to be x. Okay. Then we're going to add the quarters, which is a 0.25. And number of quarters is going to be a 47 minus x. And then the total, the worth of the 47 coins is going to be 950. Okay, so we're going to have to solve for x now. So let's just multiply the 0.25. The first one is already 0.1x here. Okay, plus. Now the 0.25 times 47, giving us the 11.75. So I'm just going to write that 11.75. then minus 0.25x. Now remember you have to use the distribution property here. And then I have a 9.50. So if I combine the x over here, so I'll have what? Minus 0.15x plus 11.75 equals to 950. So now we are going to subtract 11.75 from both sides. Okay. On the right hand side, I have minus 2.25. And then I have a minus 0.15x. Now we're going to divide both sides by the minus 0.15. Okay. And then we should get the number of dimes here, right? So divided by minus 0.15. And I have 15 dimes. Okay. So if we have 15 dimes, then you just subtract 15 from 47, then you should get the number of quarters, right? So the quarters is going to be equal to 47 minus 15. So that will be what? 32 quarters. Okay. So if you multiply, 32 quarters by 25 cents, and then you multiply the 15 dimes by 0.1, then you should come up with the $9.50 there. Okay, now let's move on to the next question. As I said, you're only going to have 9 questions here, so we're almost there. So next question here is that the linear graph. So we want to find the equation, okay, of a line containing, okay, 3 and negative 1, and the parallel, okay, to the line 3x plus y equals to 1. Now remember, if two lines are parallel, their slopes are the same, right? So from here, 3x plus y equals to 1 here, so we can find out what the slope is. So we can rewrite this as the slope-intercept form. Subtracting 3x from both sides, I have y equals to minus 3x plus 1. Okay, because I subtract 3x here, 3x, we get minus 3x there. So now we see that the slope that we got here is negative 3. So that's going to be M1. So in order to have two lines are parallel, okay, the condition was that M1 is equal to M2. So now we know that what the slope is, minus 3. Then we do know the coordinates that we have to go through. So what we're going to have here is that we're going to use the point slope form to set up the equation there. So that means I have a y minus y1 is going to be equal to m times x minus x1. So here, this is going to be my x1 and y1 here. All right. So y minus 1 equals to m, which in this case negative 3, and x minus x1, which is a negative 3 there. So here I have a y plus 1. I'm just going to rewrite the, expand this using a distribution property here. So I have a minus 3x and plus 9. Okay? Now if we subtract 1 on both sides, then I have y equals to minus 3x plus 8. And that should be our a line that's parallel to the 3x plus y equals 1, but it's going through the 3 and negative 1. It is not necessary that you're gonna have to rewrite this standard form that you are given in the question. As long as you write it in slope-intercept form, I'm okay. All right. Okay. So now the next question is next question 8. So we are solving the linear inequality in two variables. So we have like 3x plus 4y is greater than or equal to 12. So first thing that I want you to do is rewrite it as the equation. So we have a 3x plus 4y equals to 12. Then I want you to use the y-intercept and x-intercept to find the those two intercepts here. So x-intercept means that y equal to 0. So plug that in. You got 3x plus 4 times 0 equals to 12. So then I have a 3x equals to 12. So divided by 3, I get x equals to 4. So the x-intercept is going to be 4 and 0. And the y-intercept, this means the x equals to 0. Again, plug that in. So you got 3 times 0 plus 4y equals to 12. So divided by 4 on both sides, so I get y equals to 3. So that means that the y-intercept is going to be, okay, 0 and 3. Now we're going to plot this, okay, onto the graph. So here it is. So the x-intercept is going to be 4, 0, 1, 2, 3, 4, and 0 here. So that would be a 4 and 0. Next one's going to be 0 and 3. So 1, 2, 3 over here. So that would be 0 and 3. Since the inequality is going to be greater than equal, now remember the greater than equal sign means that you have to use a solid line. And if you have just the greater or lesser, then it's going to be a dotted line. So here we have a solid line here. So we're just going to connect these two dots over here. Okay, my graph is not that good. The next thing that we are going to do here is that we are going to find out which side is going to be our solution. So I'm just going to use the 0, 0 as my test point. Okay, so my test point is going to be 0 and 0. Now, if I plug in 0, 0 to the inequality, if it makes sense, then that's what we're going to shade it from. If it's not, then the other side. Okay, so let's plug it in. So 3 times 0 plus 4 times 0, is this going to be greater than or equal to 12? 0, that's false, right? So the 0, 0 didn't work, so it has to be on the other side. So the solution is going to be, you have to shade the other side here. Okay? So that's the solution area. So you're gonna have to show your work, and you also have to show me the solution region on your graph. All right. So the last question. So this is the question 9. So this question is the the modeling questions that we did in class. So let me just write down the question here. So the average birth weight okay, of babies born to 22 years old mom is 3,280 grams. Okay, and to 32-year-old mom okay is 3,370 grams. Okay, so we're gonna have to assume that okay the age of mom, okay, so age of mother, okay, and the birth weight is linear. So that means that as the mom's getting old, baby's weight is going to be increasing, okay, as mom's age increases. So we're going to answer the two questions over here. So the first question here is write the linear equations. Okay, so write a linear equation that relates okay age of mother to a birth weight. Okay, treating okay age of okay mother as the independent variable. Okay, so once we come up with the linear equations, we're going to predict the weight of baby. So predict weight of baby born to mother who is 30 years old. Now we are not saying anything about because you have your baby at older age, baby's going to be healthy or not healthy. That's not what we're saying here. We're just going to look at the relationship of mom's age and the the birth weight of the babies. And after that, we can do more research on what's happening to the baby in terms of health and others. So let's look at the question A first. we need to come up with the, equation there. So I am going to draw the graph over here. So it says the mom's age is independent variable. So that has to be a x. So that's going to be a age, right? Mom age. Okay, mom's age. And the y value here on the vertical axis is going to be the weight, birth weight. Okay, so that would be a birth weight. So I am going to plot the the ages and the birth weight here. So if let's say this is a 22 years old here. Okay. So if you are 22, your baby's weight is going to be let's say 3,280. So we're going to call this 3280. So we're going to have a point over here. So now this represents the x, which is a 22, then the weight, which is a 3280. Now next one's going to be if you are 32 years old. So I'm going to put over here 32. And then it's going to be 3370. So I'm just going to put 3370 up here. And then we will have something over here. So this point represents the 32 and 3370. So, if I connect these two dots, then that's going to be my graph that represents the relationship of mom's weight, age and the baby's weight. So we need to come up with the equation for this. Okay, so here we go. So we know that we're going to have to find the slope first. Okay, so m is going to be equal to, so why don't we call this x1, y1, then we're going to call the x2 and the y2. So y2 minus y1, so you got 3370 minus 3280 divided by x2 minus x1, which is a 32 minus 22. Okay, so that's going to be our equation, the slope here. So let's find out what this is. So 3370 minus 3280, I get 90. And the bottom 32 minus 22, we get 10. So slope's going to be a 9. We're going to use the point slope form to find the equation. So I'm going to use x1 and y1 here. So you got y minus y1, which is a 3280. Now the slope's going to be 9. And then x2, the x1, which is 22. So x minus 22. So we're going to put them in the slope-intercept form here. So you got y minus 3280 is going to be 9x minus, we're going to have to multiply 9 times 22. 9 times 22. I have 198. All right, let's add the 3280 on both sides. Okay, so now the slope-intercept form of this one is going to be y equals 9x. Let's subtract that 198 from 3280. I have 3 minus positive 3082. So that should be our equation that represents this green line over here. Okay, so here's the, okay. All right, so let's answer the second questions. What will be the, weight of the baby if the mom is 30 years old? Right, it's 30 years old here. So now remember the X is representing the mom's age here. So if we want to find out the X equals to 30, we're just going to have to plug that in. So Y is going to be 9 times 30 plus 3082. So that means that we have what? 270 plus 3082. Okay, so let's just add those two plus the 270. I have 3352. So we are predicting that if the mom is 30 years old, and we anticipate, okay, the baby's birth weight is going to be 3,352 grams. All right, guys, so this is going to be similar questions that you're going to see on the test Wednesday. If you have any questions after watching this video, please contact me. Okay? All right, I'll see you next week. Goodbye.